Okay, cool, let's get started. So, since last time, I've had a bit of feedback from Electronic Eel on what he thought might, or what they thought might be a good way of doing things. So, I have reworked things slightly, and we now, hello Esden, we now have 2 CAN interfaces on one Glasgow port, and both CAN interfaces have a DE9, and both of them have Spring terminals as well. So if I just give you a quick show around what's changed. Still got the patch panel, which I think is probably quite important here. I've included a note just saying common pinouts that we've seemed to have come across in the last stream. I'm not sure if there might be others in the future, so just leaving it as user-defined, basically. Hi, my Aegis. I hope I'm saying that right. On the channel, individual channels, I've removed the silent control. I should probably actually put a little X on there. Or I might even need to pull it somewhere. Let's have a look at that in a second. My Aegis. Awesome, thank you. So the silent control is really important for situations where you're using a controller that might be built into a micro, for example, and you don't have a good handle over the signals that it's putting out. So because we're running in Gateware, we shouldn't need to make use of that silent pin. We can do it ourselves, if that makes sense. I've split the RGB LED into 3 discrete LEDs, and there's now no silent signal, so I'm using the termination signal to make an orange LED come alight. And I think that should work out nicely. I could probably actually remove that transistor and just flip the LED the other way up, couldn't I? Let's do that. Yeah, let's do that. Cut traces, I think that probably is a good idea. Let's come back to that one. Does that do the job? I think that'll do. Okay, cool. So 2 parts out of the way. Yeah, so there's no termination there's no silent pin anymore. We've got discrete LEDs for transmit receive, and they are not driven by the gateware, they are actually driven by the signals here. I suspect the way this transceiver works is if you assert a dominant state onto the bus, the receive pin also gets asserted. So you might find that both LEDs blink when you transmit, but only one blinks when you receive. I think that's probably okay though, I'm not too bothered about that. If it is an issue, we can potentially look at it later, but I think it's fine. Okay, so coming back to here, Esden was suggesting that we default to the pins 7 and 2. Now, this sounds nice because then it's compatible with things like the Bosch and Vector tools, but at the same time, my immediate usage, at least, would be an OBD2 port, and probably one of those OBD2 to DE9 cables off the shelf, so I immediately go for the other usage. I'm not sure if that's awkward for everybody, or if maybe we should have one wired up one way and the other wired up the other way to give a bit of flexibility there, perhaps. I'm in split minds about it. One of one, one of the other, yeah. I really am in split minds because I kind of don't like cutting traces, and I'd like to be able to just go for it. If you got DuPont wires or whatever hanging around, and you can just wire them up. OBD2 is it's the standard, which I think it might have been the EU put onto vehicle manufacturers to allow people more sort of standard interface. It's not just CAN on there, there are some other interfaces as well. There's I think even an analog bus on there, which I have no idea about. Cool, okay, so if everyone's happy then, I think I'll leave it as is. We can always revise it if everyone finds that they're using one set of pinouts over the other. Cool, thank you. Okay, so I did have a play with KiCad in terms of doing the layout, but I haven't actually done anything on this project yet. I've ripped it all up because of the changes I've made from Electronic Eel's comments. So we're really starting at sort of day one really on this. And hopefully we've got everything with footprints and good to go. Asden still voting for pre-wiring and saying that the OBD port or pin out is the one that if I'm going to use it, that should get it, do you reckon? Let's go back up. I'm actually really tempted by one of one and one of the other. So let's do that. Have we got a nice footprint for a cuttable solder bridge? I have to remember how to drive KiCad again. Oops. I'm going to look for in your library. So that's the so much in here. It really is massive. It's awesome. It's massive. I'm not complaining. I can't remember what your library is called, Esden. Or maybe it seems to have fallen off the face of the earth. PKL. Yeah, okay. All right, well, let's try and figure out what's going on there. I can't do my alphabet. E. Yeah, okay. Never mind. Add some new ones. Oh, it's not even at the bottom. It's not even sorted by alphabet. Yes, I might well have done that. Pretty KiCad libs. All of these chaps down here, isn't it? And then in here, I should be able to make a new part. Oh, there you go. Please just close everything. AKL, cool. Misc. Oh, you reckon it's going to go? The gigs go brr. Jumper. Is that a cuttable one? Oh, there's no footprint, so just find one of them quickly as well. Connected. Oh dear. Oh, they come by a different name, do they, perhaps? Try that again, then. Jumper. Jumper. Oh, normally closed. I presume that is NC rather than not connected. Can't see your PKL jumpers unless it's these ones. Normally closed, let's go with that. Okay. And then that has a footprint which comes from PKL jumpers. Nice. Give something largish. Normally closed. Oh, I see, yeah. Normally closed. 603 I think will be nice. What I've done in the past is quite a nice sort of I don't know how to explain it, but kind of a wedge shape which allows the solder to flow really nicely. I've got one on here. No. Oh, okay. Width of the, oh, I see. Yeah. Very good. Let's go for 20 thou, I presume. The gap is smaller as well. Nice. Okay. I'll turn that off. And I'm going to move this into place. On the top one, we will pick out the Bosch pinout. So that's 723. 3. Actually move this over a bit. Where are we going to line up? There. The 3 comes down to ground, or 0 volts. I did it again! It's the default ATI operation, isn't it, to press escape when you're happy with the wire's position. So 7 is high, 2 is low. 7 is high, 2 is low. 7 is high, and 2 is low. Nope, the other one. Reference. Pressing O will rearrange the labels. Oh. That's cool, I didn't know that, thank you, Aston. Can H and can L. That looks reasonable. Nope, wrong button. Yay. And then do the same again downstairs, but we want 3 and 5 can H and L. Can H is, so 3 is high, 5 is low. 3 is high, 5 is low, and 1 is 0. Yes, quite right. Thank you. I was looking at the wrong 7, 2, I think. Oh, I've got them all backwards, I think, because... yes, that's a very good point, too. Oh, dear me. What's going wrong here? Okay, start again. Pin 7, I'm going to take a snapshot of this, otherwise I'll just forget it all the time. So I want pin 7 on this end is can H, and pin 2 is can L, which is good, and then pin 3, which is actually this one, is volts. I want to put a bit more space in between these ports as well. The legend is wrong. I think I was looking at these numbers on the 1x9 header instead of these numbers, which are the DE9's pinouts, if that's what you're referring to. Load again. No, oh. This new tooling, isn't it? I have to say, actually, since using KiCad on the last stream, I then went and did another project in Altium again, and I kept pressing all the wrong buttons, so... it's quite funny how that goes. No, I don't want to do that. I want to do something more like that. Copy that, and we've got one spot in the middle. Something like this. One spot. Looks good. Right, so these pins are now for the DE, or for the OBD2 cabling. So pin 3 is can H. 3 is can H. And 5 is can L. And 1 is 0 volts. Like that. That does the job. Screenshot is awesome. I have to say that out of all the things I came across in the last year or so, screenshots made a massive difference to my life. That sounds a bit sad, doesn't it? No, I can't be bothered. I'll sort that out later. I need a little note here though, so we're going to say that wired by default for vector. And then we're going to say wired by default for OBD2 to D9 cables. Cool. Very good. It's 2020. Yes, if the screenshot discovery is the best thing that happened this year, that is indeed an indication of 2020, isn't it? Right, let's start again. I think that's popped them all in, 10, 11, 12. I'm fine with them starting the numbering from the end of the previous run. And let's bring in any changes. Ooh. Nice, okay. Now, this is something that you lot will probably be able to tell me about. I previously wanted to just turn off all reference designators for all parts, and I couldn't find a good way to just select everything and turn off all the reference designators. Right, so hi Omni Technomancer. We've now got 2 CAN interfaces on the single Glasgow port, and this will be a board that sits beside Glasgow instead of on top of Glasgow. And for each port, we have a DE9 as well as spring terminals as well. The patch panel is available, but by default, each of the ports is wired for one of the 2 common pinouts that we located. So CAN 1 is wired for Bosch and Vector, CAN 2 is wired for the OBD2 to DE9 cables. Have a look in the edit menu. Text and graphic properties. Oh, bingo. Oh, okay. I decided against that one. I have to choose references set to not visible go. That's the one. Nice. And grey means it's not visible, I presume, so I can just kind of ignore them. My downward facing camera is not connected. Let me just get that up and running. Come live in a bit. I was going to show Glasgow and try and decide the orientation of this. You can buy cables off the shelf, kind of like this. So they're crimped on both ends, ready to go. And it depends how when you buy them, whether it's this way up or if there's a twist, so this connector would be put on the other way around, for example. And I think we're going to go with a straight through connector, which means that if we have Glasgow there, we want the key to be on the outside of the board. So I'm going to stick that this way. This is going to be far left of the board. Then we can have the connectors on the far right. I'm just going to move all of this rubbish into somewhere else for now. I'm pressing the wrong buttons. Half mil grid, that sounds fine. Oops. This is then one of the spring terminals, which, if we have a look at the 3D view, I think I've got the models in, there we go. I don't know if that's going to be comfortable in terms of getting them to have access over the top, so I might put them beside instead of behind. I might do that, Eston. It's been on my list of things to do. When I was doing, I can't remember what project this was, I just bought a load because I didn't really care about the length then. And then it was that was done kind of thing. Probably sits something like that, doesn't it? Yes. Cool. Now this is something where I quite like one of the features from Altium, which is to be able to do rooms. So because we've designed it in this hierarchical view, each of these CAN interfaces would become a room, and I could lay out the components, and it would then place things in the same sort of situation with traces and pores and everything as well, which is pretty nice, to be honest. Ooh, what have I done there? Oh, I moved the drifters. Okay. Can I? There we go. Will be for this one. No worries. I'm not calling you savages. Not yet, at least. How can I move apart? Oh, there we go. I'll line up those pins. Nope. On grid with each other, and then I'll bring some wires through. I did remember, well, I didn't remember, but I did. I think it was Control Shift W. What was it? To route a single track. Shift X. Of course. Yeah. Come back and tidy it up later, I think. There we go, slash to do that. Right, so if we copy this one and do a better job of it this time. Go from there-ish to... Oh, I see the problem. Yeah, okay. Shift X. You're trying to use the Altium keys again. I'm going to be flipping them forwards, backs and forwards with this, aren't I? J10 and J12 next to the wrong part. Oh, okay. J10 and 12 are... 10 and 12. Oh yeah, you might be right. Those nets do look like they run off the bottom. Let's look at that in a sec. Sort of there-ish. Nice. Now, can I just copy those? Oh, need to get all of them. Copy reference point. Oh, nice. Put that on here. That's not on grid though, I don't think. Oh, maybe it is. Enough. Add, move that onto there. Cool. Yes, I think I agree that those are probably in the wrong places. Well spotted, thank you. Now for the patch panel, we've got to remember that fingers have to get in here. In terms of wiring them up, you go for the sort of standard 0.1 inch pin out spacing, you'll find it a bit fiddly, I think. So if we leave, there was a measure command in here, I can't remember what it was. Shift M, nope. Tools, measure, Control Shift M. So if we leave, what's that? 7.75. Let's go for 8 millimeters between them. I think that would look okay. Is that going to be 8? Yes. Cool. Then again here, let's keep the orientation the same. So square pin, pin 1 is the top. And I'd like to move it by this pad, please. Yep. We're on a grid of 0.25, 1, 2, 3, 4. 8. Oh, it's 9. I miscounted. Typical. 8.25. I miscounted again, clearly. Today is not my day. A. Okay. These pin jumpers, I'm not sure if they need a label or if they just need to be cut these if you don't want the default pin out. I do honestly feel like I want to label them, so we will come back and put them beside, I think. But for starters, we've got 0, low, high. We've got 0. Wrong button again. 0, low, and high. Yeah, I think so. Yeah, definitely. We're going to have to label these somehow very, very clearly to say that because of the way the D9 pins are labeled, they go down and then around the corner and up. So on here, this is not D9 pins 1 through 9. It's actually 1, 6, 2, 7, 3, 8, etc. which is awesome. So we're going to have to add some labels in there. Maybe even add some space. Let's think about that right now. Let's. Can I please move that? Yeah. What are we going to put in here? Is it just T for text? Nope. The button. I don't want it on the copper layer. I want it on top silk. Front silk, that'll do. And this is going to be 1. And I'm going to rotate it. Oh, what's happened to the grid? Oh no! Oh, because those are 100 thou, not quarter of an inch, millimeter, sorry. Okay, whatever. That's 6. That's 2. That's 7. 3. 8. 4. And the right layers manager. Oh, okay. Ah, yes, I think I did find that actually the other day. I clearly forgot it was a thing. Thank you. 5. Those are all over the place. Fix them up quickly. Okay, how does that look in 3D Viewer? 3D Viewer is really handy to get an idea for sort of spatial situation of things. I think that looks okay. I'll perhaps put a little bit of text saying DE9 in or something like that. And then we need text obviously on this one as well to say what that is. Grab the text tool again, and we're going to do, I think it's CANH. Oh, now, aha, okay. I've just spotted something which goes against my religion. Oh! So pin 1, in my mind, should always be 0 volts if you can possibly make that happen. Oh, I see. Oh, okay, it's this chap which is wrong. There we go. Do that. There we go. Save that, import the changes. Much better, okay. Move, rotate, nice. Oh, wrong one. Cool, okay, that's better. Pin 1 should always be 0 volts if you can possibly make that happen. And now we add the text. We're going to say CANH. Can I do justification right? Nice, let's do that. Oh, I could have done orientation for all of these ones, but never mind. Height 1 millimeter. I built up this handy test card a while ago, which has got a number of different features on it. So you get an idea for silk and trace dimensions here. You get text, and then there's also a whole bunch of holes. One of the hardest things to know is whether a wire will fit through a hole, for example, and is it comfortable or is it gripping, that kind of stuff. It's probably a rule of thumb that you can get into your head, but I am awful with numbers, and rules of thumbs just sort of fall out of my head, unfortunately. So yeah, I made up a little test card which just allows you to try it. It's very handy, in my opinion. Down the right-hand side. So what I was really going for there is we've got these bits of text here. I'm going for a 1mm height text. Now, if we look in the very bottom of that, might not be able to see it. This one right in the very corner, that's 1mm, and the silk does not come out very nicely. So I think 1.6mm generally is sort of a safe size if you can possibly get to it. Cheap to come by, I don't know. I made a bunch, so if you live not far away, perhaps chat to me on Discord and I can possibly send one for you. So 1.6. If I do a different height and with the same width, it does stretch. Okay. And so if I keep it square, that should keep the text square in inverted commas, even though the characters are actually probably not square. That's fine. Now I'm going to want this left justified, because otherwise I won't get them to line up, will I? Yeah, let me know. I can probably ship one in an envelope to the Netherlands. And that is 0 volts. Now, all of these bits of text. Can I say show only this layer? Hide all other layers? No. Is there a filter, selection filter or anything like that? Yes, the square is a funny thing. Oh, sorry. You're reading the chat, watching Facecam. What was I saying? I was trying to hide all other layers, but I think the best way to do that is probably just hide everything and turn the one I want back on. And I want to be able to edit all of these at once, but I probably can't do that. Text and graphics properties. Can I just do selected text width 1.6? This is probably going to be quite tight. Okay, no worries. If I don't pick anything, will it do this? No, it doesn't do the selected text. Okay, just run through them. Fit nicely still. Looks a bit funny when it's slightly larger. But we need to be able to read it, so let's go for it. Might see if I can get my top-down camera going again. Not sure I actually need it at the moment though. Wrong button. Select all. So, just finessing at this point, isn't it? That'll do. Not on the top of the track, and they don't quite look like they're all lined up, but actually they're not so bad from this side. Off. Give me that. Select the reference there. Oops. Going to be this probably. Yep, nice. As for these, I think we can probably move that one over. Can we center it-ish? Cool. We're also going to need labels for the spring connector as well. And again, it's CAN H, CAN L, and 0 volts. And because this is actually a board edge, or not board edge, but it's on the edge of the board, let's put it on the other side so that people are more likely to be able to see it from outside. I just turn on everything. Cool. I think this is the edge of the board line here. And so typically you go for sort of a millimetre or so in from the board. The silk, but that looks plenty, so that's good. Let's leave that there. How does it look? Oops. My, oh no, my my 3D space mouse, whatever you want to call it, doesn't really work in KiCad. I'm not sure if that's something I need to look into. Looks alright. Move it in a little bit more. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Looks good. These ones. I'm going to put them in the order that makes sense based on the pinout we're going with. Which means that this one's going to go on top. I am going to label with them with the ref des, but I'm not going to label them with the... Oh, hang on. I'm not going to label them with the pin number, because that would, or the pin signal name, sorry. That's correct. That's correct. And that one is not correct. There we go. Okay, and to put them into place and screw them in. I would imagine so. It's pretty, in terms of scripting, it's pretty flexible, I think. I've not looked at doing any of that though. Oh, come on. Oh, I haven't moved those over yet. Okay, let's do one channel and get happy with it, and then we can come back and do it. Where are we going now? These are actually a 6-pin part, but they only have 3 channels, 3 connections, whatever you want to call them. I'm not sure if I should probably be putting them down as 6-pin parts on here, because as you see, 3 of the pins are not connected. What happens if I try and put that? Yeah, best to avoid it. I don't think I want to give it a net by hand in here, but maybe I'll just do that for now, unless someone's got a better idea. And 1L. Six pin, yeah, okay. They are electric. electrically connected, yes. Do 2 by 3, does that just magic? Oh, that's the value. Well, that probably wants to be this anyway, doesn't it? Ah, here it is. And I can probably just do 2 by 3 in that. No, maybe not. What was I in? Connected generic. Oh, what? Oh, here we go. Two. Oh, odd even. Oh, okay. 1, 2, 3. We're going for not that. No letters. Top bottom. There we go. Okay. Oops. Ah. Enter's probably. I don't quite understand. Oh, it's rotated. No. Oh, is the whole part rotated? Is that why it's choosing the wrong edge? That probably wants to be top. Yeah. Okay. So this one's J6. J6. And we can be nice about this or we can be nasty about this. And I'm just going to be nasty about it. Because that's effectively what's going on in the connector, I think. It doesn't sort of look like that should be allowed, really. Oh, it doesn't even look like it's wired up. Let's go underneath. Can we make the grid smaller? Where's the grid? I don't remember where the grid is. There was a toolbar option for it. Grid settings. Let's do 25 just temporarily. No, need to do a wire first. There we go. I agree, it was really, really unreadable. Not okay with it. Are you all okay with that though? I think that kind of makes its point, doesn't it? Grid back. 100. Can't see the dots now. There they are. Oh, 50 probably. 50 mil. Cool. Thank you. Import changes. Oh dear. Need to put this there. Oh. Got 2 J6s now. Okay, let's delete this. No. What happened? Why did you delete the wrong one? Do they have a unique ID or something? Is that why it bought a new part in? I can reassociate. Oh, is that an option during click? Reassociate footprints by reference. Yeah, okay. Nice, thank you. Ooh-wee. Oops. Oh. Is there a sort of undo your last track command? Control Z. I mean, so if I do Control X and I start drawing a track and I go, oh, hang on, no, I wanted to put this elbow at a different point. I can't press backspace or sort of I can't do Control Z while I'm in this mode either. I have to come out of that mode, then I can do Control Z, then I can start going again. That's okay. Right. I think we're going on the bottom now, and we're going to go from there, slash, to here. I'm going to go from here, yep, there, and then from here to here. Redo those now that we know there's plenty of space. Okay. Those look like they're a different place. Slash. And then we could potentially put wires through for the pads as well. What do we actually want to do there? Yeah, let's figure out how to put a wire. Add a wire. Plot that. No, is that because? Oh, that's two different signals, isn't it? Silly me. Okay. Let's leave that for now. Have a look at the rest of the channel. What have we got? Can we put the schema over here? I will get on my other screen. I'm going to get the CAN channel open, and then I think if I select, yeah, so on the schematic, if I select, I'm not sure if you can see here, if I select this part, it highlights it over there, which is nice, and I can actually see what we're dealing with. Not sure if that's a good view or not. Might be a bit small. But I am referring to the schematic on the other screen. Okay. So this is the termination, which goes between CAN L and CAN H and a resistor, which is R1. Pick that up. So what we actually do is rotate that. There's CAN L. There's R1, and there's CAN H. So I'm just going to lay everything out in sort of almost a schematic way, in the same way as the schematic, so that we can get a feel for what's going on. This is the ESD protection. So we've got CAN L, CAN H like that. We've got the actual transceiver, which is the only other thing on this set of signals. Go here probably. All right. Does that look right? Yeah, that looks okay. Might be able to put that resistor on the back or something, get things smaller, but that looks quite nicely packed. Now we've got R2, which it is here, which is the resistor for the LED that's inside that package, or the diode. We've got, this is the termination LED, so I'm going to want these in special places. I'm going to lay them again exactly the same as they're drawn out in the schematic. This is the receive LED. And then we've probably got up here, oh no, there we go. This is the transmit LED. They're going to get silk, they're going to get special places, and they're probably going to go close to the front of the board. Possibly even, well, maybe in this gap over here. That would make some sense, wouldn't it? Get some LED, yeah, labels, sorry. R4 is for transmit, and that can sit underneath, if I get it the right way around. R3 is for termination, again, sit underneath. R5 is for whatever that is, receive. Now we've got a couple of capacitors for the transceiver itself, and I think that's a channel done. There you go, look at that. So these net lists are a bit tricky to work with sometimes. Okay, 5 volts, 0 volts are there. What I'm going to do is put this capacitor and this capacitor just in the middle, I think. Oh, I just remembered we meant to look up if we can just leave the silent pin floating. Let's do that quickly. It was a TCAN something. silent pin S. Silent mode, control input active high. It's active high, so we can pull it low. I don't know if it needs to be. Searching for S in here is going to be a bit unfortunate. Not sure if it's going to have sort of an internal diagram. There we go. Silent, so it's got a current sink in there, so it should sync itself low, but there's no harm for us to just drive that low by connecting it accordingly. So let's do that. There you go, we can just delete that, wire that in. Cool. I'll put that back over there so I can keep referring to it. And we can bring in the changes like that. Nice, so this pad is now also connected to 0 volts. Okay. Typically you want the ESD protection as close to the actual connector as possible, but I think we're not too bothered about being super close. We're more interested in usability from a sort of having good silk and everything point of view, I think. This could go on the bottom. I'm going to try and keep things off the bottom for this board. It's pretty simple. There's no real need to put anything on the bottom, and it just, if it does go to production for whatever reason, then it's going to be a bit cheaper, but less steps involved, etc. It might be tempting to put these connectors on the bottom. That might actually make a bit of sense, but I will leave them there for now. The jumpers, sorry. Chat's gone a bit quiet. Not sure if I lost everybody. Oh, there's a few people here. Hello, everybody. Checking up on you all. Between the patch board and I could, yeah, that's not a bad idea. You're still here. Hello. The issue with that would be that the signals are crossed. I'm not sure if you can see the nets there, or the rat nest, whatever you want to call it. So I think this side is preferred, and we can just put them, or the diode, just in line. We can run the signals or the track something, wrong side. Run the track something like this, and then off onto there, and then into here. And again, for this, we can come straight through there. The main thing, don't forget, that we're protecting is this transceiver. So long as the ESD diodes are in the path to the transceiver, I think we should be fine. Oh, that's a very good point. I could change the order on the schematic, but I'm happy with them there, I think. If anyone has particular concern. I would actually probably prefer to have it on this side than on the other side, because if you think about stubs aren't really a concern at this speed, but in terms of propagation of a high voltage as it runs down the wire, if we actually have the ESD on this side, or the protection on this side, then feasibly you could get a spike running all the way down here into the part. Physically higher, as in towards that edge of the board? Is that what you're referring to? Yeah, let's do that. On the screen in this orientation, yeah, exactly. I think it's sensible to keep things straightforward if you can help it. So I want to probably bring them in line, something like that. This is going to be under the silk, which is a little bit unfortunate. Might get some bumps in the text, but that's probably okay. I'm going to put a via on that. Not sure if you can do vias just by pressing a magical button when you're running a track, but you probably can. Actually, I tell you what, why don't we put a via on both sides like this? I need to, I can do both at once. Net 0 volts. Looks okay. You can hit V to set while routing. Let's give that a go quickly. I do that, and I do V. Ah, okay, cool. So it's on the end of the track. Nice. Thank you, Rachel. Ah, okay, so I can just push V now to plonk a via. No. The same button as for the one activating the function outside routing. Oh. Okay. Don't know why that's not working. Okay. Oh, is V switching layers? Oh, it does. Yeah, it does do that. It doesn't place a wire, but it does switch layers if you look up in the top right corner here. So that's an interesting one. Not sure if people are okay with words in music, but I might skip this one so I can remember where everything is. Okay. Don't forget, Rachel, you're probably also running the nightly, which I'm not. You can't hear the music. Oh, maybe it's just very, very quiet. You want the music? Is that better? Okay. If you want the music and you still can't hear it, let me know. I'll turn it up a bit more. Still can't hear the music. You must be able to hear it now. So we've got audio. You see audio there. Can't remember where the settings are for the stream. Never mind. I'll look into that. Sorry about that. Streaming audio track. Audio, yeah, everything should be track 6, which is selected. Have a look at this one quickly. The wrong button to be pressing. Advanced audio. There we go. And that's set to. Yeah, it should be coming through. Apologies. I'll look into that some other time. No, I do. It's got a VU meter and everything. It's bumping up and down. I've turned up lots, but never mind. You can put your own music on, and I'll try and fix that up for the next stream. It captures in the recording I make as well, so when I go back and listen to the file, it's there. I'll just turn up lots and see if that helps. Can you hear that? That should almost be as loud as my voice. Never mind. Enough about music, which isn't there. Right, where are you putting this? Let's actually rotate that, I think. Move this up a bit. Something like that. No music. Fair enough. Nice straight tracks, there we go. T-can goes in the little wedge here. There's a bit of silk for the pin 1, so we need to obviously watch out for that. But otherwise I think we're probably okay. Now we just need to be able to squeeze the CAN-L signal through here, which looks okay. I haven't set up any rules on this design yet. I'm just going to aim for sort of 6.6 or something. Let's do this again. X3 or Shift X, sorry. I'm not sure if it'd be maybe sensible to set up some rules. Root settings. No, there's got to be some rules somewhere, haven't there? Design rules checker. Minimum track width. Oh. Millimeters to not millimeters. What have we got? So 0.2 millimeters in thou is 8-ish, so that's fine. Minimum wire size 0.4 millimeters, that's probably okay. What about gap size? Never mind. Rachel might chip in a minute and tell me what to do, but until then. Through the board setup. And where would that be? In one of these buttons, maybe. File. Oh, sorry, okay. Board setup, there you go. Well spotted. Oh, right. There we go. Minimum track, 0.2. Via minimum hole to hole. What about track to track and all that kind of thing? Like minimum clearance, I guess, would be. Yeah, I think that's fine. That's sort of 8-ish thou. Okie dokie. Is there a way to just not show these? Yeah. Oh, we've still got whatever those are. Tab notes, yeah, perfect. Cool. 5 volts goes to here. 5 volts goes to here. We can then put a via. Now we've learnt the buttons. We've got an off-grid thingy. Never mind. I like the tracks to hit the center of the via, just because I'm special. A bit picky about that kind of thing. This resistor needs to go somewhere. Probably put it there. Let's rotate it, put it there. For some reason, oh, okay, only shows it when it's got selected. That's all right. And that's not going to go on grid, is it? Never mind. There we go. Okay. Need the via for this. And we're done. Oh no, I blocked myself in. Okay. Move this one to here, like that. Thank you. Right, can receive. Let's just. What are you doing? Draw some nice long tracks that we can then use to find our way back in. We're going to go and do the other channel now, I think. If you remember the schematic, we've really only got 5 volts transmit, receive, and termination. So I think that's that. Just get rid of these and bring everything a bit closer. Like that, I think would be good. Don't want it to be too big of a board. There we go. Okay. LEDs. I think if we run them underneath here, we can just bring. There's the termination, the transmit, receive signals are these three. And if we just run them on the bottom, we can bring them up to the LEDs fairly painlessly. The actual transceiver and everything is a lot smaller than the rest of the circuit. Maybe even we should be rotating that, putting this around a corner. Rid of those quickly. Just to reduce the left-right width of the board. Like that. Move these as well, because they're clearly in the wrong place now. There we go. We've got a resistor with no name. The silk screen for the R1 on that is going to be a bit difficult to squeeze in. And we've also got to get the signals through, so let's put that more like that, I think. And then we can do this. And this one really don't care about length matching or anything on this design, so that's fine. Okay. Let's re-look at the jumpers, the cuttable jumpers that we put in. What are we going to do with them? Let's put them here. We can still get nice access, and then from there, well, actually, potentially even from here. Yeah, between. Did someone say between already? Is that going to be awkward to get a knife into? I think it's probably okay. Put them on the bottom. I was thinking about it. We've already got some tracks on the bottom. Oh, I've driven over my silk there. Turned off the silk. I was thinking about the bottom. Oh. Ooh. You reckon it's fine? I'm tempted to put them there where they are. EU selects the whole track. Oh, nice. Thank you. It's handy to know. Let's turn on the silk. Okay. We need to push this around a bit. Oh. Immediately not using U that I've just been told about. There we go. Thank you, Maegas. Move all of that. No, not quite. I do this. Turn on the silk again. Like that. That's good. Yeah, I think that will be okay where it is. The nice thing about where it is here is that actually we can just wire directly into the other side of the patch panel. I don't like calling it patch panel, but that kind of what it's doing, isn't it? So let's just pop them there. Can H goes like that. Can L goes like that. And then on the other side they go down to their relevant pin. No, not like that. No. Oh. Need to stay on top of KiCad, you do. There we go. Nice. Nope, not at all. There we go. And then we can plop her via there. Wicked. Oh, we're missing the track from here for can H. Bring that out and round. No, whole thing went away. Like that, and then just make that into a T or something. There we go. Do this one nicely too. My hope is that once we've got one channel wired up and we're happy with it, the other channel will just sort of fall into place. Okay, 0 volts on here. So the the pad. That's supposed to be 0 volts, isn't it? Where's my thing gone? There is no pad. How do we leave out the pad? No connect. That's pin 5 for a different type. I don't actually mention the pad. We got the drawing for the footprint. Exposed thermal pad. It always makes me nervous when they say exposed thermal pad and then they don't tell you to connect it somewhere. I guess we'll leave it floating then. Yeah. Okay. What else have we got? 0 volts. Oh, we don't actually need to wire up 0 volts because that's going to be hopefully going into a plane on the back. And connect it to 20 kV, yeah. Keep it nice and warm. Okay, looking good. Let's put the LEDs in place then. These are things which are also going to require some silk. I'm going to grab that on the other screen again. We've got the termination, transmit, receive. I'm just going to copy one of these, I think. Term TX and RX. The diodes are the important things, the resistors are less important. And what we actually have is T2, so that's termination, that's the transmit, and that's the receive. So they're in the correct order, I think. How does that relate to bring the resistor in so I can follow the rat nest. Okay, so I think I might swap around the receive and transmit just so that it makes the routing a little bit easier, because why not? There we go. Okay, put that back there. So that's receive, that's transmit, and that's termination. These LEDs, I'd be tempted to leave the ref-des off just because we've got the words instead. But for production runs and things where they don't have the words, they should have pick and place files which tell them physically where a particular part goes on the board. So yeah, my feeling is that they don't get ref-des silks, they just get the words that explain their function. In the fab layer, yeah, exactly. It's all lined up nicely. Straight on the X. And that one's okay. How does that look? Oh, it's behind the block, which is, I think that's okay, isn't it? You're sitting over here, you're not necessarily going to be able to see them, but not too worried, I don't think. You're always going to have some kind of problem. Looks fine. Cool, let's stick with it. Yeah, putting models in my mind is very helpful, and then just reality checking every now and then. Yeah, if you put them anywhere, you'll always get someone sitting in the wrong angle. In terms of the terminal block going 90 degrees out, so could do. This one would, I guess, be out the top, and this one would then move to the bottom and stick out there. And you could bring the DE9s right up to each other. I kind of like the symmetry of having two channels that are as identically as possible, or routed and placed as identically as possible. So well, I suppose, talking myself out of it now with the LEDs, would you want the LEDs to be on the board edge again, so down here, rather than in the middle of the board where it's a bit ambiguous, is it left or right? Okay. Mirror symmetry is a thing too, yeah, don't disagree. I think I'm not going to rotate it, but I probably will do the mirror symmetry. I will put the LEDs for this channel on the edge, and I'll move that block over. Bring the DE9s together, put a dotted line down the middle. That sounds good to me. Need to put some words about these jumpers and how to cut them. Let's focus on the LEDs though, otherwise I'll get distracted again. Right, put a wire in. No. Resistors. Is your resistor. It's there. Why won't you go on grid? Anything else going on here, I think? No idea. Oh. That works. Oh, is that what it is? Subtle, thank you. Yeah, nice. Thank you. Transmit comes to here. Delete that one. That then goes to there. The receive is going to be one of those. And the termination is going to go underneath. I think I'm going to put it here. Run it all the way over to there. And then I'm going to probably run it down the back as well. That sounds promising. Let's figure out if we can actually do that. Some footprints won't mirror though. Can probably rotate it and deal with it that way instead. Tick. There we go. These are my tails. I'm going to put this out here. No. Thank you. And then finally the transmit. I think I'm going to bring that down the back. The via. Not going to be on grid though, is it? There we go. Via there. On the other layer. No. Okay. Receive. Yeah, let's just put it down to here-ish. Oh, I see. Mirror parts would be nice, hey? That's good. Even though I'm planning a pour probably for the ground, because I'm probably only going to do 2 layers for this, there's no real reason to do more. The 5 volt probably needs to be routed with something somewhere, so I'll just put vias on the ends, and we can come back to that later. Oh no! Delete the entire track, why don't you? You have to be quite specific, don't you, with the positioning of your mouse. Okay. Channel 1 done. These are all just 5 volts and 0 volts. 5 volt, 0 volt. Yep, I'm happy. Everybody else happy? Channel 1. Save. Now, what we want to do, is mirror this part. Well, not mirror, but move. So that it sits. Was it 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same grid. Oh, we're on 0.2 grid now. That's annoying. So easy, and I have been doing it quite a bit today, just pressing the wrong buttons. No, that's the wrong grid, isn't it? That's annoying. 12. I just get a cursor up without actually moving it anywhere. X 18864 somethings 18875. No, never mind. Get all those lined up. Looks good. Maybe worth locking some of these things, actually, thinking about it. I need to lock all of those. Locking, lock. There we go. No, we don't want to move it. Cool. This one, I think, needs to be reworked because I think it's no longer in line with the plan. There we go. Let's just confirm that that is 18725. 18425, okay. Even that's not right. Put the tracks in there. On grid anymore. No. What's wrong with that? Do you reckon I put the other thing on a 0.2 mil grid? No. Okay. This is 95 and I don't know what it was, 95 by 195 and 45. Let's put this on a 0.25, right? Okay. One, 2, 3, 4. 1, 2, 3, 4. 2 millimeters. Put that on there, like that. Still not dead on, but never mind. I will pretend it is. And I'm sure that these will work out. Don't want that. Do want that. Do want that. All right. Do that. Paste there. Oop. Oh, they're not long enough. Was unexpected. Never mind. There's only so much perfection you can go for, isn't there? Okay. We need the other half of the patch panel then, and that I'm going to move it off the middle pin. It's there. These are the wrong size. Oh, I've already got them as well because I copied. Yeah, I think we put something in there, didn't we, earlier? I don't know why that's two segments of trace, but it's fine. Just wire it up. Never mind. Right, copy this. Center of that pin. Center-ish of that pin. There. Still got high, low, 0. And we've still got the same order on the other side of the patch panel, which is good. These then go somewhere. These are the cuttable trace or jumpers. Oops. 0 volts. What is that? Can H. Oh, it's can 1H. Have I done something wrong? I have, look, that's why I was getting so confused earlier. Can 2H. Can 2H. Right, that's better. Bring the changes in. Yes, look at that. Now I've got the wrong parts. Oh, it's so annoying. What have we got? 50.5. Remember for L. 50 point mind 50.5 and that, and then this one is 48, which is good. 48. Nice. Okay. Wait, I'm confused. Why do you want to be routed through to there? You're joking. I've got these backwards as well. Okay. That's great. As expected, because the extra trace segments, if it doesn't merge them always, this one, those cases. Yeah, no, I think I've just got my parts wrong because I didn't fix my nets previously. Let's just do this, I think. Yeah, lock it. I mean, unlock it. It's probably fine, isn't it? Can't see the tracks over the holes or under the holes. Good. Okay, you happy now? This is routed. Oh, the net will be on the wrong. Oh, sorry, the track will be on the wrong net now, won't it? That's annoying. I should have moved the whole thing. So it's these nets that I want to delete, I think. Move this. Not that, that's good. Yes, move it. Move all of this to yeah, to center on there. Like that. Okay. Well, now we've got a cross. Now this part is the wrong one. 10, 11, 12. Oh, it's amazing how much of a mess just getting two net names wrong can make. Looks like those aren't in quite the right place either. Better. And now look at the nasty crossing, cross we've got. I'll come back to that one. Let's just get this in place now. What are we on? 2 millimeters ish. That'll do. I think that's the courtyard as well rather than the actual part, but that's fine. Okay, back to where we were. This is the one with no crossovers, which is good. Uh-huh. These knees are going to drive me up the wall, I think. Look, just keep flip-flopping. Right, that'll do it surely, I was about to say. Okay. Right, we're there. Let's leave that floating for the moment. This one, got some crosses. What we can do is use the back of the board. 0 volt, don't care about, we can put that wherever we like. And we're going to put it down here somewhere. So these two, there's a track left over. Yeah, it can be moved. What I'm going to do is put it here, I think. And bring it up from that via. And this one, I'll put it there. Bring it over the front. There we go. One goes there. And this one, I'm going to put a via on that knee just there. It's not X though, it's V. There we go. And this one can go in line with that in there. Very good. A little bit of a crisscross, but never mind. And now makes me want to put these in the middle again, which I think should work out. That you delete. Probably need need to get keyboard button presses on the stream at some point as well for this kind of thing. Would be quite helpful. People that aren't familiar with KiCad can see what's going on. Myself included there, by the way. Right, yeah. That's enough. There we go. Cool. So we've got 3 cuttable traces in the middle in the same places. And it kind of self-describes what they do, I think, as well, a little bit there. This one now, yes, I want to move it. I want to put it in line with that, and I can't remember how far away we put it now. 12 from there, and let's go from here. 3, 4, 5, 6. 6-ish. And get that from the other one there, can't we? From the X coordinate, the absolute positioning of it. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the X position is that, 188.75. Yeah, not far off. Okay. Copy them from this pin. And they're in exactly the same place. Oh. Oh, that's interesting. So it's on grid there and off grid there. Oh, on grid again. Oh, that'll do. Don't care too much. This is a 5 that got left behind from something. That JE? I put an E in something by mistake. No. They're J1 and J6. Is this part of the merge, potentially? Or the reassociate? Oh, there we go, J6. I don't know what was up there. Never mind. Hexadecimal decimators, yeah. Keep you on your toes. Okay, what we're doing now is same again, but the other way up. And then hopefully this will go sort of there. Oh, how nice would that be? Nice little board. Okay, interesting. Grids are a fascinating deep dive topic, which I'm not going to go into today, but how to and how not to and all that kind of stuff. It's so opinion based as well, which makes it difficult to talk about properly. Everyone's got their own ideas about stuff. I'm going to just mirror this here. So if I rotate that, I'm going to mirror it here, just because then I can kind of keep my brain intact. So I'm going to try and keep my brain intact, that is. I think that the mirroring isn't going to work out because of the components we were talking about earlier. So we might have to do more mirroring than we had originally anticipated, or more work to do the mirror. This is R7, which is the termination resistor. Yeah. Oops. Mirror components to make our lives easy, or easier, or harder, easier right now and harder later on when we get the wrong parts, etc. Yes. We are looking for R8, which is, yeah. Press N again, keep pressing that. Go here-ish. I'm doing a 180-degree rotation because we can't do mirrors, basically. And I think if you look at how the tracks come out here, if we just, instead of rotating upwards, we rotate downwards, then I think we'll all be okay. There'll be some rework to do around the LEDs to get them in the same order, but I'm okay with that. That'll be fine. I'm using the wrong word. I'm saying mirror, but doing a rotation. This then goes here-ish. Probably in the wrong orientation for now, but that's fine. Those are paired up. That's related to you. That's there with its. No, that's someone else's. Pushing N, don't push N. Disable N as a hotkey. That's go with you, and that's go with you. Right. Clean that up a bit. Let's bring this into view. I'm going to try very hard to be not too precious about this. I'm very good at being too precious about layouts. If it gets boring, yell at me. We're going there. Yeah. So I haven't quite got the hang of it. Every now and then I expect that when I select a component, do something with it, and then I expect to be able to hover over another one and press M and for it to move, but it moves as the one I've got selected. Just a brain thing though, more than anything, I think. Okay, let's wire that up. Shift X. Goes sort of like that. One goes sort of like that. And like that. And like that. And like that. And like that. There we go. Looking a bit close, to be honest, so let's redo this line. To be more like that, better. Can L then comes down through here. Does it fit? It does fit, that's nice. That'll do. 0 volts, this is just for an LED, so that's okay to be little wire. Got a little wiggle on here. That. Capacitors. Oh, what have I done? Save. Oh no, not like that. There we go. See. These parts don't take any power at all, really, so I'm not fussed about big chunky traces or anything like that. I think it was Rachel's stream we were talking about the importance of putting smaller capacitor values close to the part, and that helps with what is basically an RC filter in terms of isolating and suppressing the high frequency signals, or noise, or whatever you want to refer to it as. Yeah. Oh, LC? I would, yeah, okay. LC, RC. Maybe it's a bit of both. I've always thought of it as an RC filter for some reason. Don't know why. Are they? Okay. Right. That's a fair point. I've never really thought about it too carefully. Vias are inductors as well, that kind of thing. Where are we going now? Can L, can H. Oh, this needs to be 0. V for via. This is the transmit and receive signals. Okay, let's move it into place. I think that's good enough. Oh, poo. And as I said, we're now just going around a corner downwards instead of upwards. Instead of mirroring it, we've rotated it basically. We're going to go here-ish. I think that. No, let's actually do that and that. We did here. We did actually give them corners there, so maybe let's give them corners. Undecisive much or indecisive much? Got some dead space in the middle of the board, which is frustrating. It's frustrating, and I think I still want the LEDs to be at the edge though. Maybe I can put a nice logo in there or something. EDN analysis graphs. I shall have to remember that one. Thank you, Rachel. The kind of thing I probably should know. But I'm not great with terminology, and I learn stuff and forget it quickly, etc. So I might read it and go, oh, this! I've done that a fair few times. Right, in terms of the orientation of this connector, it is correct, which means that our signals are actually going to come out on the outside and in, which I think is all right. Need to make a pour and stuff in a minute for the 0 volts ground, whatever you want to call it. Can I just change layer, please? Yep. Okay. I'm going to go to the bottom of that connector here. Oop. Slash. Doing Altium buttons again. Oh, he does great videos. Really, really good. going on here? Oh, it's under the cursor, is it? Yes. Okay. Getting crazy for a second. Okay. So it's the transmit receive. That is actually the no connect pin there, pin 5, so that's fine. And the termination. Oh, well, yes, yeah. I quite like full screen cursors, but that was admittedly not a great example of full screen cursors. I need to get these in the right order again. I've probably just mucked it up. Oops. Let's get these as well. Nope. Yes. I'm going to copy them off. I won't be able to do that, will I? Because we've mirrored it in inverted commas. We can't rotate it easily. Okay. I think term is a little bit sort of 1.5-ish from there. Oops. Move. One and a half-ish, that'll do. Getting technical. This is the receive LED. It's here. And its resistor. This is the transmit LED, goes here with its resistor. And this is the termination LED with its resistor. Cool. What do we do over here? We just put all the resistors in line, that's fine. Rotate all of these, methinks. That. Line it up with the X. Line that up with the X. Can't do that, never mind. Near enough. Turn that around. Cool. Each of them gets a wire to 5 volts, which we might change later, but deal with that when the time comes. And that gets a wire to probably 0 volts. Oh no, to the termination signal, of course. The other end of the chain gets the 0 volts. 0 volts just goes off to the side. Tell you what, let's use ye olde screenshot tool. Whoop. Okay. The termination signal is there. The receive is there, and the transmit is there. So I think we probably come out something like this. Oops. From there, and that can go out. Oops. Run off the edge of the screen. And be our little tail. Termination's already on bottom, and we're going to need to get it out of here, so let's use the bottom that it's on. Put it on the bottom copper, bring it to here, and let's continue on the bottom copper and get it out. Something like that. Ooh, off. There we go. A. The order of these signals might change when we find out that actually on the Glasgow pin or Glasgow header it's slightly different. So that, put that to a via and run it under here. Another via here and off to a tail. Sort of like that. Cool. Oh no. Like that. That'll do. Okay. What cool picture can we put in the middle of this then? I say cool picture. I'm not sure that's necessarily what I mean. Need to sort out the board outline at some point as well, because that is not what we want. But I think that looks pretty good. I haven't got a model for the opto isolator. I did have a rummage, but nothing showed up, unfortunately. So it is what it is. Thank you. Seems to be coming along nicely. Just going to move that off the via. Okay, what have we got then? All of these 0 volts and a 5 volt. So that, I think, is a prime candidate for, I don't know, doing something with. I'd quite like to use the bottom as much as possible as a really huge bore. We'll come on to that. I think these tracks, for example, can be shifted onto the top. Wrong button. And again, the way I'm routing that one is interesting actually, because it goes. Can I get the whole net? Select the whole net. Highlight the whole net. So select single track connected. All tracks in net. There we go. Yeah, so it comes in on this spring terminal. It goes down to the patch panel and then up through the ASD protection to the transceiver. I could take a shortcut here, but then that potentially causes issues with the SD protection. So I think I'm happy with how it goes there. This one then comes on the top layer. That's that. In terms of keeping a nice solid ground pour, it's really important to not cut it up. That's not what I wanted. Yeah. Oops. Wiggle, wiggle. Nope. Yeah, there we go. Yeah, so keeping tracks on the bottom as short as possible and as minimal as possible, then we get nice solid ground plane on the bottom. These ones, I can certainly do this one on the top. Do that. The other one, I think probably not so easily. And again, this is going round the big loop, but I think that's what we want really. That knee, please. Thank you. What we can do, instead of routing it all on the top, is we can just put some of it on the top. And by some of it, I mean as much of it as we can. So take that to here, put a via, and then run it to its destination like that. No, I didn't want a via there. Sorry, I pressed the wrong button. What's a full screen cursor? You see how I've got my little pen that moves around with my mouse, and then there's a line, white line that goes left and right, and one that goes up and down as well. That's the full screen cursor. And you can turn them down sometimes so that they are sort of partial screen or even just a small crosshair. Yeah, the crosshair, yeah. And it's kind of a thing that some people like and some people hate, etc. We can actually push that bottom copper to a via here as well, probably. Reduce that even more. Nice wiggle. Cool. A really huge pointer. Okay. Let's bring these out then on the top. TXD. Let's start with the termination because that's the closest signal, so that gives an indication of how far out we actually need to go. Just end it there. This one. End it there. Oops. Not quite where I meant to have it, but never mind. Oh, that one's not where I meant to have it either. Don't know quite what I'm doing there. Never mind. I'm sure it'll become clear at some point. Again, here we'll just use the. Ooh, we could go inside. No, let's not go inside. Use this one to go up and do the next one. These ones are, what are they? Are they twisted? Yes, of course they're twisted. 100% twisted. That's fun. What are these ones? These ones are partially twisted. That's okay, we've got them on the back already, so we can link those up. If I'm going to bring that to here, untwist it, back onto the top, and down. Oops. Thank you. Oh, for goodness sake. That run it? Oh no, that's okay. Wondering if it pushed it off on the top. That looks, yeah, I think. That's that all wired up. Still got lots of zeros and fives. I think they're coming though. No CAN or LEDs or anything like that unwired, which is nice. Okay, how are we going to do this one? This signal actually goes underneath already. It goes underneath to there, so we can bring it all the way in. Whoop, done. That. Next is this one. We're going to bring it to. I can't do that. Delete this. Put a wire in. Where are we going? Over there. Okay, I'll come back to that one. But now that we've done that, we can run this one over the top and directly in, which is nice. Give space for the wire, and then we can put a wire in here, sort of like that. We can go underneath to there, wire in there. Let's just sort out that nasty net track, whatever. And let's sort out that, which I'm unhappy. Okay. Oh, look at that. I think now is the board outline. I also just noticed that there is a very dark page template frame, whatever you want to call it, which we are not at all centered on. Might be able to see it a bit better there. A bit hesitant to move this because everything's going to come off grid, but It won't show in the goers. Oh, that's fine then. I do tend to put frames around my boards usually, so that's kind of why I thought it might come out. Right. Board. Graphic polygon. We're going to have a root layer or something. Keep out the edge cuts layer. Edge cuts. And I just draw a shape on it. I want to just draw lines. As in graphic lines rather than tracks, I would imagine. Of various shapes and sizes. Yes, cool, thank you. I'm going to put the grid to 1 millimeter. And we're going to go 2.5 mil that way, millimeters. 2.5 millimeters that way. I'm going to just draw a square. Oh, hang on, let's put the fab lines on because then we get the edge here. I'm going to put a square frame in first for the board outline, and then I'm going to come back and put in a rounded corners and adjust the square, because the square gives you something to work off basically. That. That's interesting. Left isn't always one grid distance. It seems to move 2 just now, and I wonder if it's to do with the zoom level as well, potentially. If I render that, oh, it's done it. Look at that. Nice. I think that's looking quite smart. We need some notes for these cut traces and to say which is A and B, and also to say that this is wired for whichever it was, the vector pinout, and this is wired for a D9 cable. Oh, sorry, OBD2 cable. So we'll come and do that in a minute. We've got to put all the ref deses down as well, so that's something to do. How do we draw lines in KiCad? Oh, sorry, arcs in KiCad. We draw the radius and then the start and end. Okay. So we draw the radius and then the start and end like that. And then we move this into place. Nice. Putting the cuts on the back would the cuts? What do you mean by that? Oh, the cut jumpers. Yeah, that's true. I was in edge cuts mode rather than jumper cuts mode. So we're going for a 2 millimeter arc here. You can do quite a lot smaller, but we've got plenty of space, so that's fine. I think we're going to run round. We should already have the fab notes. Oh goodness, there's so much text in here. So these F fab is presumably fab notes, and that includes the part numbers, which was a little unexpected. We also want the front silk ref des, and they seem to be grey. If I just edit that, turn it on again, front silk. Default to the fab layer, yeah. Let's use the text and graphics properties, all footprint references, turn them on. Oop, there we go. If they're hidden, they're not on the fab layer, so I have to go around and hide them, presumably. Visible, yes, no, yeah, okay. So it's still visible in KiCad, but maybe they don't come out in the Gerbers or whatever other artwork we're doing. That's messy. It's being weird for me, okay. That's good to know. I might update actually as well before I produce Gerbers and finish tidying up. I don't know how old this one is now. Let's bring this back down to 0.2 millimeters, get these all nicely lined up. You can use the same tool to go by layer. Oh, I see, okay. So I could say all of the front fab text properties get disabled. Is that what you're saying? And that should take care of all of the part numbers which are popping up just now. Let a quick go. So if I do filter by layer, front fab, turn the visibility off, and I want footprint values probably. The value box below the footprint refs box. Footprint values. Yeah, okay, cool. Yep, it's not visible. That's not visible. That's not visible, but I can still see it. Oh, that's okay, no worries. I'm going to turn it off because otherwise there's too much text going on. These LEDs, I don't want to see the ref des, but there is a D2 in here, which is on the fab layer. Good, so I can turn these ones off. Well, I mean, there's space. Let's maybe leave them on. R2, put C2 over here, and then we've got another capacitor under here. So there we go, C1. When it comes to wires, I don't know if the render will show us. It looks like they're sort of semi-tented by the looks of it. So now you also move the ref des to the fab layer. I also disable the %R ones. Oh, really? Let's turn the fab on again. So we've got here this one, which is %R. Is that the one you're referring to? And you turn them all off. Okay. I think if I can, I'd like to have the ref deses on the top silk rather than moving them to the fab layer. And presumably, if you were to move the silk onto the fab layer, you'd have a duplicate. Which is the problem I think you were referring to, maybe. Let me have a look at the wire. The drill, 0.4. There's no sort of, what's it called? Solder resist pullback or anything listed here. Aha, fair enough. I have to admit that printing isn't something I often do, so if we can get the ref deses in place and easy to read, then I think I'm going to be okay. Okay, if you say they're tinted, I'm happy to believe you. You can always review the Gerbers maybe later. I wonder if it's just being a bit weird, as you say earlier. A4, let's move that. Oops. Finish. Oh yes, oh I see what you're saying. So if we have a look at here, we've got C1. Ooh, what happened there? Ooh, nice, you can middle click and sort of go places. Yeah, so the C1 I was going to talk about that and got distracted. Be nice if that wasn't there, or if the via moved potentially. And it looks like we can move the via. Let's just have a go at that. That did what I was worried about earlier. It moved the entire trace. It didn't reshape it, resize it. If we put the via in the center of the C, why are we going underneath again? Oh, for here. Get rid of that. And then on the top again, run that trace. Oh, of course, you told me about grab last time, didn't you? Thank you. Okay. So now if we look at it, middle click, yeah. That's kind of, it's dodgy, but it generally works out okay, I think. The R3 might have lost its 3 there, so let's try and move that via maybe. This is all a bit, if I just press G, oh, I see. Very nice, then I have to redraw the net, or the track anyway, because it's now not isometric or whatever the word is, 45 degrees. Cool. A2, let's move that out of the courtyard, just, yes, let's move. Yeah. Accidental emoji, they're the best kind. Okay, J9, let's move it please. Let's put it on the bottom, because there's no real space on the top and it'll be a bit ambiguous. These don't have ref deses, I'm fine with that, because you cut them or you don't cut them, and you don't need to try and place them or anything like that. Q3. Oh, D5, okay. Get the diode from up the top. Where is it? Yeah, I did, but no, I didn't. Oops, what happened? Bring my design back. Okay. Got the capacitors again. Move that one out there. And that one out. There. Can we get the via into a nice place again? Yes, I think we can. So we can just draw it here. Or we could put it elsewhere, but that's fine. We could also. That's no, front, please, thank you. What are we doing? Lots to get rid of. Doesn't seem to undo loops. Your feet broke, okay. If you had a question, feel free to speak up. There's going to be a trying to let me not go off grid thing again, isn't it? Or even not to change the grid. These R's and these D's are getting quite close. Great. Cool. That term is close, but I think it's fine. This 0-volt wire wants to move. Might even put it all the way over there. Okay. Looking good. Now we want to do a pour. Graphic polygon, don't want a graphic polygon. Build zone, I presume that's what we're talking about. Thank you. Yeah, let's do the pause first and then we can come back and put text in. So let's have a play with this because I have, oh, do I have to draw it inside? No. No idea how this works. Oh, okay, choose a net. Front copper. Go. And we can't do radiuses. We have to do square edges and then... okay. And that's now a pour, is it? Be able to see it? Can't see it. Properties. Do I have to re-pour or anything like that? I do need to calculate it. Yeah, B. Okay, cool. Thank you. No visual difference. Doesn't seem to have appeared on the board. Okay. Do I need to connect it potentially? Let's pour it over this. B. No visual difference. Still no pour. What is that? Oh, that's the 5-volt supply. Ooh, funky. Oh, there we go. Okay, it was maybe too small or something. Cool. If I bring it to the board edge, what happens? Can't get there, so let's make it so that it can get there. Oh, this is a nasty shape. Let's make a new one. Grid of 1 millimeter. Front, 0 volts. Well, let's do back actually, 0 volts. Like that. You can get swoopy edges with the fillet options. Defaults are completely crap. Oh, look at that. Even kept away from the edge nicely, which is cool. It's done thermals. Very good. That's not going to work, is it? It pays to spend some time in there. So, where is in there? Is it tools? Looking in the options. Need to find the options first. Application options. Oh, okay. Cool, okay. Cornering split the. Presumably you have to give it a non-zero fillet as well of 5 millimeters, and we can see it. Yeah, look at that. Awesome. Thank you. So I can draw a rectangle and it will give it a nice fillet, which is nice. Nice. There was something I spotted just now, which is a island, which is here, and it's got no rat nest, which is a little concerning. Because, I mean, maybe the DRC would pick it up, but... Can I turn off pause? Temporarily? Clearance to 0.2, minimum width to 0.2. That's your rule of thumb, is it? Thermal clearance, put that 0.2 as well. Oh, I think I remember. Thermal relief spoke must be greater than the minimum width. Oh, whoops. 0.4, there we go. Yep. And yeah, here we go. I remember. I had a poke at this earlier. Thank you, thank you. By earlier, I mean a couple of years ago when I tried KiCad last. I'm very bad at using terminology which is not, lined up with the durations involved. Okay. Let's bring this down here. Oops. Oh, the grid. Let's bring it here. Get rid of that. Turn that on and press B. There we go. You've now got a wire connected, or a connected, whatever you want to call it. Or I'm going to rerun this. B and turn it off again. Okay, this is actually going to go on the top. Yeah. Run term on the top side past D78. And here, yeah, then we get this little bridge. Well, actually, let's just do that because then it's a little under a bridge on the bottom there, isn't it? Good idea. Thank you. Up. Thanks. Get rid of that. Get rid of that. Oh dear. Ding 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 ding. Lots of sections. Underneath. Another via. Let's redo a bit of this as well. Oops. Where are we going? Bottom, under here, via, up. Looks good. Well done, Rachel. Thank you. B. If we were to put this, put this like this, we get a shorter or smaller slot, whatever you want to call it. I need to turn this off so I can see. And actually, that's fine. Yeah, I think that's okay. Oh dear. Come on. The T-junction. Is this better for you? It's better for me. Okay, let's check our ground pour. This one's big still. Let's redo that. From here through to there-ish, and on top. Definitely. I'm pleased to hear it. Unless I've just destroyed the the definitely. There we go. That's better. B, much smaller. To be honest, it's not a design. To be honest, it's not a design which really requires this kind of thought, but can't hurt, really, can it? I made myself a silkscreen issue. Oh, so I did. That's probably why that vial wasn't there, isn't it? I just grab it. No. Okay, wiggle in curd. Never mind. What's the other option here? The other option is actually we go round the other way. Let's just do that. I like that more. Even less of a slot. I can't see, I can't see, I can't see. You really got to get better at getting loops, KaiCad. You really, really have. I'm picky when it comes to silks, I'm afraid. I like them to be all sort of lined up and stuff. Oh, semi-transparent. How do I do that? High contrast. I can do this one where you get the outlines. Is it in what's it called? There's like a whole system settings thing, isn't there? Preferences. Preferences. PCB new, display options, color schemes. Thank you for the link. Oh, it's got to be a whole scheme, has it? Okay. I will look into that later then. I will just struggle on for now. Oops. This one. Shift X. Slash. That'll do. Better than it was, I think. Still got to hook up the 5-volt lines. This one's got a big slot in it. And actually just run that underneath. Oh, me, sorry, hello. You can adjust the default color scheme. It's the alpha slider in the layer color setting. Was that in preferences? Oh, the layer color, as in maybe if I click on here. Oh yeah, there we go. Opacity. I'm not sure how I got that up now. Click on the arrow, okay. So if I put that to like 60%. Can't get this. There we go. I don't know what incantation it is to get the... Oh, it does even the traces as well, not just the pores. Interesting. Go for 70. Just click a lot until you get it back. Okay. Change layer color. That's going to be better than clicking a lot until you get it back, isn't it? I was clicking on the arrow. Yeah. Oh, sorry, on the colour itself. Oh, maybe you have to click once and then double click on it to change the colour. I see. That's why it wasn't working originally, I think, or initially for me just now. All right, let's put this under here. Let's do a fire. Get rid of that, and that, that, and that, and that. Turn this off because it's still too much, I can't see. No. Maybe I pressed the wrong button. Okay. Grab and slide. Yes, grab and slide. Apart from now, I want it to be further down. Oh. Whoop. V for via. Another V for via. Thingy. Thingy. Oh, no. No. Amazing how much of driving these tools is understanding what it's trying to do to be helpful and clever. And once you understand that, you can kind of deal with things a lot more easily. Right. Can transmit. Another slot which is quite large. I think I'm just going to pull these two apart so there's a bit of gap there for that plane to come through, and otherwise I'll leave it. Let's also get rid of that wiggle. Okay. In fact, let's just get rid of all the wiggles because we can. That one's quite large as well. What can we do about that? Oh, we we don't even need to be going on the bottom there. Let's not go on the bottom. So here to there. Just like that. B, show me the things. There we go. Okay, looking nice. 5 volts needs to get spread about. We can do that. Helpful and clever, yes, definitely. Yeah, I was thinking of a top pour of 5 volts. Wouldn't hurt, and we can just bridge each other where they don't fall through, or whatever you want to call it. Let's go for a 1mm grid again. Copy that. I'm not sure if this is going to work, by the way. Copy that, paste it, edit it, front, 5, go. Seems to have worked. Got a track in here which I'm going to get rid of. So that has put thermal in. We have no idea if there are any islands now. I'm not sure if that's something I'm missing in terms of how it talks about, how it shows things. That island is actually shown, isn't it? Good. That's also an island which is shown. Yeah. Can I go through it? No, I can't go through there. I shall not try that then. I can just run that across the bottom. Track. Oh, okay. Make it bigger. Width. Okay, nice. 0.5? I was going to go bigger than that. How do I just do that and it happens? No, I'm on the wrong layer. That's not going to help. There we go. Oh, that's a bit big. Bit big. Can I edit the track? I can. Let's go for 1. No, let's go for 0.75. That'll be plenty big enough. Millimeters? Do I need that in there? Okay. Cool. That's that one. What have we got now? This little island here, which would really rather like to not be an island. Just hop over there on the end of a burr. I don't think it matters too much, does it? Press the wrong button. V, there we go. Flash. That's tight. To make it look nice. Oh, make a grid smaller as well. There we go. We get any? No. Yeah. What? There we go. No, we don't get anything in there. Sorry, I missed some chat. So that works. You pick the root fresh, not the same unit of measure as you're using, but it helps in terms of adding the millimeters, I presume, that one. Good to know. Practical, thank you. It seems like all the other 5-volt lines have been wired up just by doing a pour. How nice. How's it looking? Oh, we got loads of yuck down here in terms of missing pour and things. And the board over. Back should look fine. It does. Okay. So we've got something up here around R1, D1, and some other bits there which we can probably address. Same again here, same there, and then some yuck there. This yuck is because, probably because of this track. Question is, do I care? And should I just do a no net or would that work? No net, 5 volts. Priorities. Ooh, big number, low number. Let's do do a -1. You can't do negative numbers. Okay. Let's pick the 5-volt one. Oh, it does seem to have poured. Give it a priority of 10. Oh. Can't be no net. Oh, okay. All right then. Let's just get rid of that. No net, delete. Don't care then. What are we going to do about these? Probably don't care. Probably don't care. Kind of do care. Kind of want to just plonk a wire down. Lower priorities don't show up under higher. Okay. Yuck. I need another wire down here. I'll just run a line up there quickly. On the back. Of course, 5 volts. Can I copy that? I can't, but I can copy that. Oh, oh yeah. No, yeah, there we go. You can mass edit wires. Good to know. I'm nearly there now. Never mind. Yeah, okay. I can probably just draw a line straight through these as well, can't I? There we go. B. Not pretty on the back, but at least we've got filled in on the front. Here, what we can do, same again, I think. Just because. What happened there? You were telling me how drawing a track, or pressing V, sorry, would create a via. And it wasn't working earlier, but it did work just now. So let's try that again in a sec. Let's just move this one. There. Bone. You're still not pouring. Oh, because it's got no net. Might do all of those onto plus 5 volts. I can. There. Oh, that's funny. Oh, no. What's going on there then? Oh, of course. This one. And this one. Nice. Filled in. Oops. Same again here. Boop. No net via, no net track. Oops, wrong button. Plus 5, not plus G. Yep, cool. And then there was one other place, which was here. Can I rotate it? I can rotate it. Put it there. No, yeah. Oop. Plus 5. Wicked. We've got to have some words on here. What do we want then? We want some kind of identification for channel 1, channel 0, or channel 1, channel 2, sorry. And we want some words to say that this is wired for, what was it? OBD2, and this is wired for, and the author, of course, yeah. For vector, cool. Put some nice big words on the front silk here and say can 1. And again, referring to the trusty card, I'm going to go for 3.5 millimeters because that's nice and big. Oh, that's massive actually. Need to make the thickness bigger, otherwise it looks funny. A bit bigger still. Probably looks quite good. And 1. Gonna go. It can. And 1. It can probably go here. Hopefully we can get one on the other side as well. And then I can rotate it, but that's not really what I want to do. Can't flip it because it does something else. Okay, that's fine. Just have to do it by eye. Can 1, can 2. Let's actually move can 2 out. Cut to rewire, I think we'll say. Cut to rewire. Wire. And we're going to make that 1.6, I think. bit big, and I can probably, put that here with an arrow to both. See if we can draw an arrow. With the connector text, I quite like having it aligned to the edge of the connector, so 0v is more obviously the pin function, as in this text here. I'm okay with that, yeah, we can move that over. I had some funny head stuff going on with the alignment of can H and can L versus each other, because obviously you want the C's and the A's and the N's to be all lined up, but then the H and the L is a variable width font, so the whole text doesn't line up. That's okay. I think I'm through that now. Right, put an arrow. Not sure if there's, oops. Yeah, oh, there we go, we can just do that. Not sure if there's a favorite type of arrow. I like curvy arrows that look a bit more like this, maybe, if I can actually draw it. Oh, I could put a curve on there. That's very exciting. Apart from that's not the kind of curve I wanted. I was going to go for something like that, and then fill it in. Edit, edit, can't edit. Thickness, go for 0.25. Can't edit more than one at a time. A graphic poly. I think that's what I did. Oh. Okay, sorry, yes, I was going to do this. Oops. Apart from we've still got a tiny little gap in there, and I need to edit all my lines again. Oh, can't be typing. Tiny little hole. Tiny little hole. Make this bigger. And that will fill the hole, but it also makes the nose look funny. Oh dear. Probably more effort than it's worth, this, isn't it? Right, that's filled in. Looks chunky now, that's a shame. I can probably make the wire thinner. Oh, sorry, the stem, whatever you want to call it. Oops. Got to rewire. Yep, move that in line. Nope. Nope. Well, maybe. Pick the wrong one, of course. Okay. Copy that from here. Rotate it round and put it here. Oh, they don't line up. Oh no, they don't line up! That's just typical, isn't it? Tried so hard. I think it probably was, yeah. Get these tracks all into their proper place again. Right, top soak, got to rewire. Nice. Then we're going to say probably vector pin out and OBD tool. I haven't got much space here. excuse me. I'm really intrigued by the default of 1mm high text, because that's pushing it. 1.2 mil is probably fine, but 1 mil, unless you've got a nice friendly fab. Okay, I'm willing to give it a go. Where are we going to put this then? I'm going to put pin out. Oops. Pin out vector. That. I want it to be obvious. For that reason, I think I want to put it here. And for this one, put what, 3 in? This is going to be OBD2. A photograph. Ooh. Oh, is this? That's not 1mm text, is it? Oh, okay. It is interesting. So I can't remember who I got this board made up by, but it wasn't. That they didn't have a particularly decent, I don't think, silkscreen. Like Bosch Park, for example, I think have got really shiny printers. Whoever did this, I don't think have got such nice equipment. But the 1mm text, you can make it out, but it's not sort of stand out in your face clear kind of thing. Could well be down to the font and the size, but yeah, never mind. That's better. Let's have a look. Oh, huge. Oh, interesting. Nice. Speaking of, I think we were going to put something like this on the back side of the board, weren't we? Might even be easier. We don't need these kinks because don't need the kinks because the DE9's got offset pins. Thank you for the image, Rachel. Initial or default? Initial pinout's too long. Default's going to be too long as well. Initial pinout vector. That is horrible. Pinout, I think, works. Pinout. That's it. Are we okay with that? This is probably something which maybe should go on the back of the board, actually. Underneath the connector. Copy that, paste it there, rotate it, put it on the back. Need up in there. Need to mirror it probably. I think that's a much better idea. Default pinout vector all in one long line like that. Nice. Yes, happy with that. Off there. Oops. Default pinout OBD2 cable. Oops. I'm going to put Bosch vector in there as well. What's that look like? Yes. Nice. I'm going to put the can 1, can 2 on the back as well. And I think I'm going to put it here, but on the back, obviously. Silk, mirrored, can 2. I've lost it. Oh, there it is. mirrored back. F to flip. Ah, thank you. So that's that. And then let's put the pin numbering of the D9s in there. And possibly the CAN H, CAN L on these three. I don't think that's so important actually. Let's put the pin numberings of the DB9, D9. I'm going to use your 1mm text. Or even I'm going to give 1mm text a go on the back. So this is pin 1mm mirrored back. Excuse me. Rotated and popped there. Let's get rid of the pause and the front copper, and then we can actually see what we're doing. Okay. Paste, 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 paste. Ooh. Oh no! All the grids are just off, aren't they? F-silk question mark? Oh, and turn off F-silk. Yeah, I could do. It's just getting rid of the clutter more than being absolutist or whatever you want to call it. Ooh. Two o'clock again. How did that happen? Okay, this is a... yes, metric imperial things don't line up very often. Three, 8, 4, 9, 5, and now a little bit of weighting. Go from there to there. That's not doing anything. Oh, I'm probably drawing that on the front silk. Yes, I think I am drawing that on the front silk. Frustrating. Try again. There to there-ish. Copy that. And then if we do one here, stretch it out to there-ish. That's good. I mean, it's not perfect. Not at all perfect. Oh no! There's no sort of snap to center of pad, is there? And I don't want to change the grid to the other one because that's probably not going to be good either. What are these going to be? Never mind. Let's just have a look at what that seems to be like. Oh, look at that. I think that looks okay. Silk's not got perfect registration anyway, so it's always going to be a little bit off. Cool. And then I'm also going to put the... No, I'm not going to put the CAN low, CAN high stuff on the back. Do that one. Looks good. Cool. Yes. Okay. I think that's happy. But look at one of these little thingamajigs that Beston's put in there. Nice, actually. I'll see if I can find an image of what I usually do. Where am I going to go? Believe it or not, this is actually the previous thing I did with this CAN chip. So here's what I usually use for termination. It's this kind of arrowed whatever. And there's no solder resist between them, so the solder does sort of obey quite nicely if you put goop over it. I've only got the 2 renders on this one, but yeah, that's what I usually do. But that's a normally open, obviously. And that was an old design with no models. I only had a handful of models. I just couldn't be bothered with that. So yeah, there you go. Yeah, you want to put my name on it. License. Oh, license. That's a really good question. Something I don't really think about enough for this kind of thing. I'm okay with all those slots. This can 1 slot. Let's just have a quick look at that. Front silk, front copper. Can 1. There's a slot. Oh, here. Oh, that can be sorted out. Come on, let's do that. Put a wire in there. And draw the rest on the top. Me, please. Thank you. Not super pretty, but there we go. Oh no, we've lost the 5 volts in here. That's all right. Cool. Yeah, I will certainly look into licensing. I was planning on putting the open source stuff all over this, and obviously it's in GitHub, or the progress so far is in GitHub. So I will be adding this to it. I honestly don't know much about the licenses and what they really mean. It's kind of an issue, perhaps, on my part. This is finessing now, isn't it? I need to stop. I'm going to skip this song, but you might not be able to hear it still. Cool. How do we run DLC on this, by the way? Silk, that's front silk. Presumably, if we save it, we can't do save because we've already done it. Tools. No music still. Oh, okay. That's strange. Last week, I'm pretty sure it was coming through. The red bug. Aha. Refill all zones. A plotter icon. Okay. I think I will do that off stream. Don't know what that means. 0 problems. Okay. And this checks for unconnected pads, clearances, etc. Cool. All right. Well, that's good. I need to put my name on it. I need to put some license on it as well. And I'm going to probably order these if I'm happy with it. I'll give it a couple of days just to sit and fester in my brain for a while. And the project name, yes. Let's do the project name and my name quickly now, otherwise I'll not do it. Back silk, I think, probably. T for text doesn't work. So designed by, is that what we're going to do? And stream. Do I put and stream? 1.6. Tell me if you feel like you should get some credit, stream people. And I'm also going to put the Glasgow 2x can add-on. Is there a dash in there? Capital O. I'm going to put this at 1.4. No, sorry, the other way around. This at more like 1.8, and this at 1.4. For some reason my brain's not doing the backwards text today. Usually I just read it like normal. Be up in the top left corner, there it is. look so. You're right, bit of spacing issue. I was going to put a little note on this as well to say connect to a Glasgow port, 5 volts. To Glasgow 1.4. Oh, that's tight. What size is that? 1.2. Let's go with 1.2 again here. Better. Glasgow. Can I flip the whole board over and see it as if from the back with all the layers sort of piled up correctly? Flipboard, here we go. Oh, okay. Never mind. How do we do bottom side, back layers there? Oh yeah, but it's still got the copper on top. Never mind. Okay. What else do we want? I probably do. All. Yep, I'm happy, I think, with that. Oh, my 2 Glasgow is upside down compared to all the other writing. That is actually a problem, I'm afraid. Oops. Probably just. Yep, cool. All right, I'm going to leave it there. Thank you, everybody, for your support, particularly Rachel. Very kind of you. I will be sort of checking this over the next few days / weeks. Hopefully not weeks, but I will be planning to get some boards made up pretty soon, I think. And then the next challenge is going to be getting this all working with a Glasgow and some gateware which actually does something, and one day possibly plugging it into a vehicle or at least some kind of sensor so that we can read values, check that it's all good. I just remembered I was going to put some holes on it to mount it, because at the moment it's got no holes on it. I might do that off stream. Have a rummage. It might be best to. Well, I suppose we could have a quick look at what the Glasgows do, because we could potentially just copy it, couldn't we? They've got quite a nice whatever this is. Is that pad? Yeah. Should we just? Can we copy that? It's not a footprint as such. Copy. This is not going to work, is it? It is a footprint? Oh, it worked though. Nice. Oh, mounting whole pad. Okay. Can I put down a part, add a footprint? Okay. Mounting whole. Look at that. Okay, let's probably put that in the schematic. Let's just do that really quickly. Schematics over here. I'm going to put the form mounting mechanical whole pad. There we go. Does Esden have one? No. Or at least not by that name. That's okay though. Put that there. H. Mounting whole pad does not need to be visible. Copy that. And put in a 0 volts. H for hole. Hole. Oh. Oh, H for hold. Sorry. Yes, I see what you're saying. On the ref desk. That's fine. Now, I'm sure there was a way to filter this. I have to filter it in the other view. In this view. Yes, I know. Filter by mounting hole. And in here they have used an unknown. That's just that. Have a look at the schematic, it's probably listed. There it is. MK. Mechanical pad, this one. Go for it. See what happens. No, type it in here quickly, see what happens. Oh, it's a Glasgow specific. Okay. That's not going to work then, is it? Might be able to just copy it. Discard. Discard. Thing. The in library. But I like their one. Mounting hole. Much going on. I don't know how big this was. It's probably bigger than that, isn't it? Here we go. Oh, that'll do. I'll have that. Can I copy the name? No. So M3 via pad. Oh, M3 pad via, sorry. Not found. That's fine. Oh. Right. This is in the... Everything locks up in funny ways in KiCad. Close that, then this will become responsive again. In mounting hole, 3.2 M3 via pad via. Thank you, Rachel. Mounting hole, 3.2 pad via. Nice. Save that, do that. Cool. Bring it through. Remember which button this one. Update. There. Want it all. That's going to go in this corner at some point. 1mm grid. I'm going to go for that, I think. Otherwise that's going to affect my writing on the back, but kind of alright. Turn these off. Do not need them. I haven't quite got enough space on this corner. Come back to that one. Then again here. Ooh. What am I going to do with that then? I think if I shuffle them up. Ooh. Gonna look alright. And then a line. Ooh. Oh, I've got to turn my grid up or down. Two. I'll do. And oh no. front silk line. That, I guess. Not on grid, but never mind. Okay. Oh, that looks alright, I think. Okay. Oh, yeah, okay. That's fine. Got here. Let's take a snip. Is there? Goes there-ish. Yeah. Front silk. Again, in mind. Yeah, that's fine. Look at that. Okay. Not sure there's much else to put on this board now. To Glasgow. Pin out vector, pin out OBD, cut to rewire. NHL 0V. All those pins from the D9. I was wondering if we need, actually putting what a Bosch and vector pinout is. So how would we do that? We could put the text here that says what those signals are by default. Let's just do that. Sorry, I keep extending this stream, don't I? It's 2:30. Ooh. Do show all back layers. Let's turn off that. Yes, do that. I think that's a very good idea as well. I'm going to close these things which I just opened. And I'm going to steal my schematic onto the other screen again. Okay. Can 1 remain awake forever? Oh, you're in New Zealand, are you? Very good. Yes, I have a difficult relationship with sleep, I'm afraid. So staying awake forever is one of those. Be nice. Insomnia paired with chronic fatigue and other things is not great. 1.2, let's go for. Does it fit? Oh, that's tight. Let's put a canal at 1mm mirrored on the back. That'll do. Okay. Can 1 has can L on pin 2. Pin 2 is that one, so we might need to do something about that track. Can H is on pin 7, which is very close by. And 0 volts is on pin 3, which is also really close by. I'm going to call this ground. Look at me go. Bye, Rachel. Thank you very much for hanging around. Appreciate all of your support and input on driving DX. No, not DX Designer. KiCad. It's very kind. Thank you. Where can I put this? I think it might. No, it won't fit there, will it? And possibly just go in those C's like that. Grab the wire. Okay. Now we need to do the other one, which is can 2, and the default for that is can H is on can H is on pin 3. Really? Oh yeah, okay. Can L is on pin 5, which is all the way over here. And 0 volts is on pin 1, which is all the way over here. Well, that's different, isn't it? Nice. Ooh. I think we can live with that L being a little bit smushed, maybe. Bit. Cool. Oh, we got to move that text up here as well. Very good. How far can we go? We can go quite far. Yep, brilliant. I'm happy with that. Cool. Well, things are going well, thanks, Eston. I think we're pretty much finished and I'm about to pack up. We've got a pair of CAN interfaces, which I think we've put all the notes on the board that we want. So we've got the patch panels, and we've got cut here to rewire. We've got the default pinout listed for each of them. We've got the spring terminals as well if you want them. We've got the transmit receive LEDs along with the termination LED on the outside of the board. We've got to Glasgow note by the connector, so this sits next door to it, doesn't go on top of Glasgow. And then on the back we've got details on the project me and the pinout for, or the default pinouts for the DE9 connectors, just so that it's sort of more clear. But yeah, I think that's all looking quite good, to be honest. Got some corners on as well, some mounting holes. So yeah, I'm going to try and get this made up. I'm going to order some boards, get some parts in, and the next step, if this works, is going to be some gateware to make it work. Just catching up on the chat. Still wonder if horizontal text with lines to pins would be clearer for Bosch. You're referring to this one. Yeah, they are quite ambiguous with 3 and 8 and things, aren't they, a little bit? Yeah, the next step will be the gateware, which is a bit nerve-wracking. There's all sorts of things that CAN does to make itself a little bit more resilient, like bit stuffing, which I've not really fully understood ever before. So we'll see how that goes when we get to it. But yeah, no, I think it's going to be a good challenge. Pop that there. A bit close to the hole otherwise. Can we put on the back silk a little tiny line which goes from here to here? I don't really like that, but I think I agree that it's necessary. Tell you what we could actually do is just say low, high, and give. Actually, I like the brackets. Put them back in. But that saved us quite a lot of space. It's a little bit obvious, hopefully, that we're talking about can on this board. Give. There we go. So if we do that, we've now got plenty of space to draw lines. And low can go to, don't even know what it's supposed to be, 2. High can go through to 7, just dodging that via. And that can go through to 3. That's horrible. Let's space them apart a bit. Low like that. Traffic line, there we go. Go for that, I think, and that straight through that via, which we can probably hopefully move in a sec, and then that. Does that have the same dimensions? I think if we did that, it might. How does that look? Need to move it back a bit, but I think that's much better. Maybe if we did. No, I think that's fine. Stuff them to bits. Yeah. I'm looking forward to it, actually, and I'd love some help if anyone wants to get involved in the can gateware. Low. I think those ones are obvious enough, but maybe let's copy this one so we get the spacing right and the consistency. Yes, there we go. The grid. That'll do. Is that in the right place? I think it is. Can't see that purple for the red. Oh, yeah, I'll do. Hide all. Show me the back silk. Move this out. And it's suspecting that we've just driven into some pads and stuff. No, that looks alright. Cool, okay. High, low. I want to move this one back. Oops. Move that one back. There we go. How's that Omni Technomancer? Look okay? I think that looks way better. Thank you for commenting on that one. I'm struggling to believe that that pinout's correct for the OBD2 cable. There's 3, 5, and 1, which is what's picked there. That must be right. Must be. Let's do GitHub. I think I've got a picture that I was planning to use on the repository. There we go. So that is not 3, 5, and 1, is it? What will that be? Oh, hang on a minute. Have we got the wrong DE9 connectors on here? Right, I'm going to call that a day for the stream, I think. I'm going to put a note for myself to in here. I'm just going to do a to-do confirm DE9 pinout footprint, because that would be really annoying if that was wrong. Otherwise, oh, it's licensing. Let's put that in. Yes, exactly, Esden. Yeah, now the part I've picked, this one here, is actually, I believe, the correct part. Well, I suppose now that I've pulled that up, we might as well have a look at the pin out, mightn't we? Apart from you'll probably find they're not numbered in this data sheet. Yeah, I'll look at this later. The issue being that the opposite side, I suspect, will have a pin out which is the mirror image. So that would be really, really, really annoying. So it could be that the model's wrong and the footprint's fine. It could be that the model is correct and the footprint is the wrong one, potentially. So I will look into that one. But yeah, I think I'm going to stop because nearly 3. I don't really think so, but better check. In terms of... my point was that, yeah, so instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, I think it would go 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, that's on my to-do list. I'm going to close up, I'm going to commit that, and I will see you all around. Hopefully next Wednesday I'll do more stream, and I'm not sure if we do some anticipatory gateware for this, because I probably won't have boards by then. I might do something else because I've got a couple of other projects which need some attention. So yeah, we'll see how that goes. But anyway, good to see you all. Thank you very much for joining, and see you around. Bye.